Hello friends, welcome back to Pharmawise. Today we are going to discuss a topic from semester 1 of first year B.Pharm from Pharmaceutical Analysis, and it is errors. I will try to explain what are errors, what are different types of errors, and what actually it means by the terms accuracy and precision. So let's start with the example of accepted true value and your measured value. Okay, see, we all know that the boiling point of water is 100 degrees centigrade. Okay, this is the accepted true value for the boiling point of water. Now how it is derived or how it is fixed? It is fixed by carrying out several experiments at the several corners of the world by several scientists, and they come up with a average value which we accept as a true value of that particular measurement. Like I said, the boiling point of water, we consider it as 100 degrees centigrade. Now if you carry out the same experiment in your laboratory and you come up with a value of 98 degrees centigrade for the boiling point of water, that means you are not accurate. Are you getting it? If you come up with a value, if your measured value, if your result matches with the accepted true value, then you are said to be accurate. And when your result do not match with the accepted true value, you have encountered an error. So error is nothing but the difference between accepted true value and your measured value or your result. Okay, so this is error. Now why do errors arise? There are several sources of error. There are many different factors which are responsible for occurrence of error in a pharmaceutical analysis. Okay, but first we will study what are different types of errors which can arise in any analytical measurement. Okay, so basically errors can be classified into two major types. The first ones will be determinate errors and the second one will be indeterminate error. Now determinate, as the name suggests, determinate means these errors can be determined, these can be identified, and if identified they can either be avoided or corrected. So determinate errors can be avoided, corrected because they are determinable. But the different type of error, another type of errors which is indeterminate errors, are actually random errors which cannot be identified, which cannot be avoided or corrected. Determinate errors are the major sources of errors in pharmaceutical analysis. So we will study what different kinds of determinate errors can arise in a particular measurement. The first determinate error which we come across is instrumental error. Now as the name suggests, instrumental error is nothing but the error arising due to use of faulty instrument or equipment. See, the equipment or instrument which we are using for analysis, if it is not calibrated, then it can give rise to certain degree of error. And as we know that error is introduced due to an instrument, by calibrating it and by taking proper care while handling the instrument and by operating that instrument by a skilled professional person, we can avoid or correct the instrumental errors. Okay, the second type of determinate errors are operative errors. Now this is the most common type of error in the pharmaceutical analysis. Why? Because operative errors are arising due to the person who is operating the instrument or equipment. Means these errors can also be referred as personal errors. Now why these happen? Because of the lack of training, because of the lack of skills. If a person doesn't know properly how to handle a particular instrument, he is sure to make some mistakes. These mistakes will result in the arising of operative errors or personal errors. So how we can avoid it or how we can correct it? Operative errors or personal errors can be avoided or corrected by either following a standard operating procedure, or by giving proper training to the personnel so that they know how to handle that instrument and how to avoid the personal mistakes while carrying out the measurement. The next type of determinate error is chemical error or reagent error. Now chemical errors or reagent errors, it is self-explanatory. The terms are self-explanatory. Chemical errors means the errors which are arising due to use of impure chemicals or reagents. If you are carrying out a process using impure reagents, it is sure to give you variation in your final results. So it will be chemical error or reagent error. The next type of determinate error can be methodical errors or errors in the methodology. Now these are the most serious types of errors in any pharmaceutical measurement, because if you are employing a wrong method or a wrong methodology or an inadequate methodology for carrying out the analysis, then it is sure to give you some error in the final results and it will be called as a methodical error. Certain methods are inadequate for measurement of certain properties. So we have to be very sure before selecting the method for analysis that the particular method which we are choosing will give us actual and correct results. If the method is inadequate, then we have to opt for a better method, or in certain cases due to economic factors, in absence of a better method, we can go with the that method, but we can apply some correction factor which can take us a little bit closer to the actual value. So these kind of errors are determinable errors, determinate errors, which can either be avoided or corrected. Now let's move on to indeterminate errors. Now indeterminate errors are random errors whose source we cannot figure out, and as we cannot figure out the source of the error, we cannot avoid it or we cannot correct it. For example, the same analytical measurement carried out by the same analyst in same laboratory under similar conditions, still the consequent readings differ. Now why this happened, we don't know. Then such kind of errors fall under indeterminate errors or random errors. Now I will tell you what do you mean by accuracy and precision. As I told you, if your measured result matches exactly with the accepted true value, means agreement of measured value with true value, it is called as accuracy. Means if your result matches exactly with the true value, it is called as accurate result or accuracy. And reproducibility of result is called as precision. Now we have to understand one very basic point here. If boiling point of water is 100 degrees centigrade, this is the true value. My result comes boiling point of water, this is my result, my measurement, it comes 98 degrees centigrade. You can easily see that the result is not at all accurate. Now what is happening is, whenever I am carrying out the same experiment, every time my boiling point for water comes 98 degrees centigrade. Every time, whatever times I carry out the experiment, every time it is coming 98 degrees centigrade. It means certain kind of error is introduced every time consistently in my results. But if you look at the results only, the consistency in the results is there, the reproducibility of results is there. So these results are said to be precise. Precision means reproducibility of results. Precise results may be accurate or may not be accurate. This point you need to understand. Accurate result means your value matches with the true value. Precise results means every time you are getting the consistent value. It may be correct, it may not be correct. It may be accurate, it may not be. Okay, this is the difference between accuracy and precision. Now I will tell you one more point. How the accuracy is expressed. Now what is accuracy? Your value and true value should match. Whenever they are matching, there is accuracy. If they are not matching, then they are not accurate. means there is an error. Now we can express the accuracy in terms of error. Then the very simple method by which you can express error is absolute error. In absolute error, we just take the difference between measured value and true value with respect to sign. For example, in this case, my measured value is 98 degrees centigrade and my true value is 100 degrees centigrade. So the difference between these two is 2 degrees centigrade, and with respect to sign, my value is less. So I'll write it minus 2 degrees centigrade. This is nothing but the absolute error in this case of experiment. So this is how you can express the accuracy in terms of absolute error. I hope I have covered the major points under this heading errors, the different types of errors, what is accuracy and what is precision. I hope this information will help you write your question correctly and accurately. Thank you so much for watching. Keep watching B.Pharmawise and I'll see you with the next one. Bye-bye.